This video is about direct and inverse variation. And what that is that's going to tell us how the y value and the x value relate to each other. And when we use direct or inverse variation, we're going to have some value k, which is called a constant of variation. And for direct variation, the way that's written is, you notice that I have y, which is my output, is equal to some constant times k. Some constant k times x. And so if I want to rewrite that and I divide both sides by x, then I get that y over x is going to be equal to k. And that's kind of important. And that means that for direct variation, anytime I take the y value and divide it by x, no matter what points I use for that particular problem, it will always yield the same value, k, and k is a constant. And of course, if I wanted to work this a little bit differently, I could say y is equal to kx, and now then let's divide both sides by y. And so I'm going to get 1 is equal to k times x over y. And I divide both sides by k, I would end up with 1 over k is equal to x over y. And 1 over k would be a constant also, because k will never change. So what that means is that as long as I get y and x on the same side and k on the other side, or 1 over k, then I'm going to have a constant value. One thing unique to direct variation is, let's consider what would happen if I would increase this x value. So I'm going to take x and I'm going to make it larger. Well, because y is also a numerator over here, both x and y are numerators, y would have to increase also. So that's the one big characteristic of direct variation. As you increase x, y is going to increase also. And one way that you can tell, if you would have some particular problem, say that I would have x all over y is equal to 10. If I can get the y and the x on opposite sides, like this, I can see that they're both numerators, and therefore it has to be direct variation. So in direct variation, once again, the y and the x, when they're on opposite sides of the equal to sign, are both going to be numerators, or they're both going to be denominators. And another characteristic of direct variation is that, notice now that I have y is equal to kx. It kind of looks like a line, and it is, but for direct variations, we'll never have anything added to it. So if I would have something like 5 added to the equation over here, this would not be direct variation. So direct variation, once again, it would just simply be y is equal to kx. K would kind of be like the slope, and if nothing's added to it, the line for direct variation would have to be passing through the origin, and so that's another characteristic. So remember that there's nothing to be added or subtracted from it. Okay, now let's take a look at inverse variation. An inverse variation would have this characteristic, is that notice that y is a numerator, and here we have another constant which is not going to change, but the x is a denominator. So inverse variation is going to be the case where one of the variables, either y or x, is going to be a numerator and the other one is going to be a denominator. And that's going to set up the situation that, consider what would happen if I would make this x value bigger. Well, the denominator is getting larger, k is staying the same, so as x increases, the y value is actually going down. So that's why it's called inverse. Decrease the value of one variable, the other variable is going to go down. And if I would try to put the x and the y on the same side of the equal to sign, like I did over here by multiplying both sides by x, notice that now I have x and y together. Notice that x times y is equal to k. So that's also another important thing of inverse variation, is x times y is equal to k. That's indicative of inverse, where before we had y all over x was equal to k. That would be indicative of direct variation. Okay, and so I think we've covered all this. Once again, one way to tell if you have inverse variation is put the x and the y, get them so that they're on opposite sides of the equal to sign. One of them has to be a numerator, one of them has to be a denominator. Okay, let's work a few problems. The first problems I have are just kind of introductory problems. They are asking us just to tell whether x and y have a direct or inverse variation or a neither variation. So what I need to do is I'm going to put x and y on opposite sides of the equal to sign. So if I divide both sides by x like this, I would end up with the equation y is equal to 5 all over x. Well, notice that the y is a numerator, x is a denominator. There's nothing added or subtracted, so this would be inverse. Okay, let's look at the next one. The x and the y are already on opposite sides. Both are numerators, so maybe this is direct variation. But then I notice that I have something added or subtracted outside here to the x. So, and remember, we cannot have anything added or subtracted to have direct or inverse variation, so this would be a neither. Let's look at the next one. And we can see that we have a y and an x. They're already on opposite sides of the equal to sign. They're both numerators, so we can tell right away this is going to be direct variation. And if I wanted to multiply both sides by 2, put it in a little bit more standard form, I'd have y is equal to 2x. Once again, both x and y are numerators on opposite sides of the equal to sign, so this is direct. Looking at the next example, x and y are already on opposite sides, and both are numerators. There's nothing added to the x side or the y side, so this would be a direct variation. And the next one, x and y are on the same side. So let's get the x to the other side of the equal to sign by dividing both sides by x. That's going to give me this equation. Y is equal to a negative 0.25 all over x, and notice that I have a numerator and a denominator. Nothing's added or subtracted. This would be inverse. On the next one, I have y and x on the same side. They're added and subtracted, so let's go ahead and subtract x from both sides, and I would get y is equal to a negative x plus 10. And both x and y are numerators on opposite side of the equal to sign, but it's not going to be direct variation because there's something added, so this is a neither. And that's it for those kind of problems. Now let's go to another kind of problem. And this kind of a problem gives us some values in the table, and that says, are these inverse, are these direct, or are these neither variations? And the one thing we're going to do here is we need to remember that y is equal to kx for direct. So if I take that, and like we mentioned earlier, y over x would be equal to k. So dividing y by x, that gives us a constant value. That's going to be direct variation. We also remember that y is equal to k over x. That was inverse variation. So to get the values equal to the constant, I could take both sides times x, and I would get y times x equals k. So y times x equals a constant term. That would be inverse. So what I'm going to do to find out if these are direct or inverse variations is I'm going to, sorry about that, I bumped the cord. All right, so now if it's going to be inverse variation, we said that what we would see is that x times y would be equal to a constant. If it's direct variation, y divided by x is equal to a constant. So let's go ahead and try the inverse here. Let's take y times x. And so that would be 2 times a negative 12. That would be a negative 24 for that one. This one would be 4 times negative 6. That's a negative 24. 6 times a negative 4. That's a negative 24. 8 times negative 3. That's a negative 24. So we could see that when we took x and y and multiplied them, we did get a constant. Well, that would be indicative of inverse variation, so this table is actually inverse. Let's go down and try the next example. Once again, remember inverse variation. That's going to say x times y is equal to a constant. Direct variation would be y divided by x is equal to a constant. And so let's see what we have here. So we would have x times y, that's 2. X times y is 8. Well, it's obviously not a constant, it's already changed, so I know it's not inverse. Let's try the direct. So we're going to divide y by x, and we're getting 2 divided by 1 is 2. 4 divided by 2 is 2. Maybe it's direct. 8 divided by 3 is 8/3. Nope. It's not equal to 2 there, so it's not direct either. This would be neither. Let's go to the next one. Remember, inverse. X times y equals k. Direct, y over x is equal to k. So let's see what we have. So 20 times 4, a negative 4, well, that's a negative 80. 15 times negative 3, that's going to be a negative 45. So we can already see it cannot be inverse. Let's try dividing it. So y divided by x, that's a negative 5. 5 divided by negative 3, that's a negative 5. 10 divided by negative 2, that's a negative 5. Negative 5. Okay, so when I took y and divided by x, I got the same value. This is direct. Okay, let's try the last one. So inverse, xy would be equal to k. Direct, y over x would be equal to k. So 60 divided, let's take times. 60 times 1, that's 60. 30 times 2 is 60. 20 times 3 is 60. 15 times 4 is 60. So when I took and multiplied the x and y values together, I did get a constant. Remember, that gives us inverse. That tells us it's inverse variation. Let's go to the next kind of problems. And now in these problems, they're going to give us some information, and we need to write the equation that models the relationship. And let's take a look at the first one. It says, well, the things that, the bullets here. So the final equation that we write in the model must contain the x and y variables, or the variables in my problem. We can't have numbers for those, and we do actually have to have a value of k. They may not give us that at the start, but we can calculate it out. So let's go ahead and try that. And the problem we have here, it says x and y vary inversely. So I already know I can write this kind of a relationship. Y would be equal to k over x. Now for the model, I would need to have a value for that k. So maybe they give us enough information we can find that, and they do. They say that y is 4 when x is 3. So let's plug those in. So y is 4 when x is 3. So we can see that if I take and multiply both sides by 3, we get 12 is equal to k. So I've actually found the value of k. Now I can write my model for this situation, or the equation, whatever the book would say, and that would be y is equal to 12 all over x. So there's the model, or the equation for this situation. And then it asks us to do one more thing. It says, okay, find the y value for when x is 2. So what that means is we're going to take our model, we're going to say y is equal to 12 over x, and now we're going to substitute 2 in for x, and we get y is equal to 6. Let's do the next one. And this one says y and x vary directly. So this would be the model for that. That would be y is equal to kx. Once again, I don't know k, and I need to find it for the model. And they give us enough information that we can calculate that. So we can see that y is 10 when x is 20. So getting the k alone on one side, if I divide both sides by 20, I get 10 all over 20. Of course, that's 1/2, and that would be equal to k. So k is equal to 1/2. So we can write the model. And that's going to be y is equal to 1/2 times x. Now then, using that model, it asks us to find y when the x value is 7. So we have y is equal to 1/2 times 7 for x. So y would be equal to 7/2. Okay, the last problem we have is a word problem. And so we're going to have to watch units in this. And let's see what it asks us to do. It says the speed of a whirlpool varies inversely with the distance from the center. So here's what that's telling us. The speed of a whirlpool varies inversely with its distance from the center. So using S for speed and D for distance, I could set that kind of a model up. And I don't know K, so hopefully they give me enough information that I can calculate that. So let's see what we get. So we know here it says that for a certain whirlpool, the speed is at 3,000 meters from the center, so that's the distance. D would be equal to 3,000 meters. And it says that the speed at 3,000 is 0.1 meters per second, so speed is equal to 0.1 meters per second. So I think we can find K. So I'm going to put S as 0.1 meters per second is equal to K all over 3,000 meters. So to get the K alone, I'm going to multiply both sides by 3,000 meters. Of course, those are going to go away. And what I'm going to be left with is 3,000 times 0.1. That's 0.1 there. That's going to be 300. And then I have meters times meters. That's going to be meters squared. And then per second. And that's equal to K. So the constant is 300 meters squared per second. Let's see what the rest of the equation asks for. It says find the speed when you're 4,500 meters from the center. Well, now I can rewrite my model. It says the speed is going to be equal to 300 meters squared per second all over the distance. And let's forget about the units for a second when I work this. We know that the end value is going to be meters per second. So I'm just going to plug the numbers in to make it a little clearer. So speed is equal to 300 divided by 4,500. That's the x value. So let's cancel some of this out to find the speed. So I have 3 divided by 4,500. So what that would be is the speed is equal to 0.067 meters per second. So I was able to find the speed. That's the last of the problems.